effective parameter a on sine function y equals a sine theta plus q. Let us investigate the effect of a on the sine function. Consider the sine function y equals a sine theta plus q, where a is equal to 1 and q is equal to 0. It becomes the sine function y equals sine theta, which we saw earlier. The graph of the sine function can be drawn. We now take the value of a as 3. A is equal to 3, q is equal to 0. The function is y equals 3 sine theta. Now, to calculate the y values for different theta values when a is equal to 3, simply multiply by 3 all the values of y that were tabulated previously. Theta equals 0 degrees. Y equals 3 sine 0 degrees equals 3 times 0 equals 0. Theta equals 30 degrees. Y equals 3 times 0, 5 equals 1, 5. Theta equals 60 degrees. Y equals 3 times 0, 87 equals 2, 61. Theta equals 90 degrees. Y equals 3 times 1 equals 3. Theta equals 120 degrees. Y equals 3 times 0, 87 equals 2, 61. Theta equals 150 degrees. Y equals 3 times 0, 5 equals 1, 5. Theta equals 180 degrees. Y equals 3 times 0 equals 0. Theta equals 210 degrees. Y equals 3 times negative 0, 5 equals negative 1, 5. Theta equals 240 degrees. Y equals 3 times negative 0, 87 equals negative 2, 61. Theta equals 270 degrees. Y equals 3 times negative 1 equals negative 3. Theta equals 300 degrees. Y equals 3 times negative 0, 87 equals negative 2, 61. Theta equals 330 degrees. Y equals 3 times negative 0, 5 equals negative 1, 5. Theta equals 360 degrees. Y equals 3 times 0 equals 0. Let us plot the points on the same set of axes. 0 degrees, 0. 30 degrees, 1, 5. 60 degrees, 2, 61. 90 degrees, 3. 120 degrees, 2, 61. 150 degrees, 1, 5. 180 degrees, 0. 210 degrees, negative 1, 5. 240 degrees, negative 2, 61. 270 degrees, negative 3. 300 degrees, negative 2, 61. 330 degrees, negative 1, 5. 360 degrees, 0. We join the points with the smooth curve. Observe that the maximum of the graph y equals 3 sine theta is higher than that of the graph of y equals sine theta, while the minimum is lower. We now take the value of a as 0, 5. The sine function is y equals 0, 5 sine theta. Now, to calculate the y values for different theta values when a equals 0, 5, simply multiply 0, 5 with all the values of y equals sine theta that were tabulated. Theta equals 0 degrees. Y equals 0, 5 sine 0 degrees equals 0, 5 times 0 equals 0. Theta equals 30 degrees. Y equals 0, 5 times 0, 5 equals 0, 25. Similarly, the other values are found. We plot the points on the same set of axes. We join the points with a smooth curve. Observe that the maximum of the graph y equals 0, 5 sine theta is lower than that of the graph of y equals sine theta, while the minimum is higher. Hence we conclude that the value of a affects the amplitude of the graph. Therefore, when a is greater than 1, the amplitude increases in comparison to the graph of y equals sine theta, and when 0 is lesser than a, lesser than 1, the amplitude decreases. We can say that the graph y equals a sine theta is stretched vertically when a is increased. Here, a is increased from 1 to 3. Hence parameter a causes vertical stretching of the sine function. When a is decreased, as it does here from 1 to 0, 5, the graph becomes compressed. Remember that we took only positive values of a in this investigation.
Need more help? Subscribe to our channel. Can't wait that long? Ask Maski to help you and let the math finally start mathing.